Welcome, this is the AP Physics Workbook tutorial. This is Unit 8, Electrical Charges and Electrical Forces. The section is 8.C, the internal force. Here you could look at the scenario, read it to yourself. Part A asks us to draw from the point of view of sphere A, which is all the way to the left. What are the forces acting on it? There are two forces acting on it. First of all, there is going to be the force from B that acts on it, and it's going to go to the right. The reason why it goes towards the right is because this is going to be attractive because there are opposite charges. So we can write this as this is the force electrical field, and this is going to be due to let's say, you know what, it is so short here, the force here has to be longer because remember Coulomb's law. The electrical force is equal to K Q1 Q2 R squared. So the smaller the distance, the bigger the force. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's make that long. That's electrical field force on B on A. Okay, and again, because it behaves like that. Then second, we have another force here. It's going to be on C, but this is going to be weaker. The reason why it's weaker is because of the R value. So it's going to be slightly weaker. So we can make this 1, 2. And this is the electric force, the electric field force of C on A. So notice A here experiences two force going to the right. Okay, it is both due to B, which is stronger, and a little bit weaker, which is C, because C is farther away. Now, part B asks us from the point of view of B. If we look at B, you can see a couple of things happening. First, we can see that point A is attracting it. Okay, so there's a force going this way. At the same time, C, these are opposite forces, so it's going to also repel. Okay, due to C. So the two forces acting on B, first of all, it was 1, 2, 3, 4, 5, 6. This is the electric field, the force of the electric field. This is going to be acting on A on B. This is A on B. The reason why, again, like we said, it is coming in. Ooh, I forgot to do the first part. It says to, what is it? It says, yeah, no, we did it. Correct. All right, draw free body diagram, leave all the, good. Then the next part, we saw that due to C, B is going to be pushed away because these are going to be repelling from each other. So there's going to be another force here, repelling. And this is the force due to the electric field, C on B. Notice that these are going to be the same length because the R value, the distance between them are the same. So notice the R value here that pushes this object to the left is the same R value to C, which is also pushing it to the left. All right, that is why I drew them with the same magnitude vector for sphere B. Sphere C, let's take a look at what attracts or repels in C. Well, first of all, we see that C is on A, so this was blue, right? This is C on A. So there's going to be C on A was pulling it to the right. So so there was C on A. So now there's going to be force electrical A on C, and it's going to be to the same value here. That's also going to be to the left, right? So something has to balance this one out. So here, this is going to be 1, 2. The force due to the electric field, and this is going to be here. This is C on A, so this is A on C. All right. Okay. Ooh, this should be in blue. Wait, C on B. No, C on A on C, and B on A. Ooh, so this should be red. Sorry about this. This should be in red. Okay. A on B. Right? So 1, 2, 3, 4, 5, 6. So this also has to be 6. 1, 2, 3, 4, 5, 6. So this should be, right? Make sure they match up in length and magnitude. Okay, due to Newton's third law. All right. So here, so let's go back to point C. It goes to the left, A on C. Then there's also a B on C, so that is purple. And that's how many? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And this is the force due to electric field, B on C. Okay, and the reason why that goes to the right is because here, okay, you see how this is going to be repelling. Okay, so that is the reason why this one, it tries to go this way, but it repels, right? So it repels. Okay, and this was the B on C part. All right, good. Okay, now let's look. The dot here, the right, represents the system of the sphere. Draw a free body diagram showing and labeling the electric field and exerting on the system. Draw the relative length of all the magnitudes. All right, so here we are going to treat the system as the entire 3 spheres. So this is the system of all 3 spheres. So now we're going to put all the spheres together. So imagine if I went something like this. If I put it here, then I put this on here, then I put this on here. So I stacked all 3 of those charges, right? All their forces in the system. Okay, what happens? Well, we know that due to Newton's third law, they all cancel it out, right? All those forces are equal in opposite directions to each other. So since the system is of the 3 spheres, the force that each sphere exerts on each other are internal to the system and will cancel each other out due to Newton's third law. There are no external electrical forces exerted on the system, so the net electrical force of the system is considered to be 0. If released from rest, the car accelerates to the left or to the right. Explain in this situation. Well, we saw right here that there is no net force acting on the system, so the object is at equilibrium. Therefore, we can say the object remains at rest. Here's my explanation. I said that the car will remain at rest. In part D, I explained that there are no net external forces exerting on the system. Therefore, the electrical field of the system is also considered to be 0. Since there is no net electrical force acting on the system, the object will be in equilibrium. Therefore, the acceleration will be 0. And there you go. That is 8C.